Hi everybody, so this problem set 77 focuses on consecutive odd and consecutive even integer problems. And along with that we have a little extra section on fraction and decimal word problems. So let's take a look at a few examples here of these kind of general consecutive integer problems. And we have kind of an odd and even consecutive integers, so we're going to take a look at that. In this first example, we were asked to find three consecutive even integers such that the sum of the first and second equals the sum of the third and negative 10. Now, I just want to remind people that this is a little bit different than what we were doing before because these aren't just consecutive integers or consecutive even integers like 2, 4, 6, 8, things of that nature. So if we're going to generalize what these look like, we're going to have to skip the next integer over. So if I let n equal the first consecutive even integer, then my next would actually be an n plus 2, and my next one after that would be an n plus 4. So these would be my generic consecutive even integers. So now I just have to read through this and make sure that I set up my equation correctly so that I can then solve for n and figure out which particular set of consecutive even integers I'm looking for. It says such that the sum of the first and second, so sum of the first and second would be n, and then n plus 1, or plus 2 rather, sorry, equals the sum of the third and negative 10. Well, that's equal to the sum of the third and negative 10. All right, and now I have an equation that I can solve, so I'm going to do that. There we go. And now I've got my first integer, which is going to be my negative 8, and yes, it is an even negative integer. And I'm going to now say, okay, well, if my first is negative 8, then my next will be negative 6, because that's negative 8 plus 2, and my next after that would be negative 4. There we have it. Okay, let's look at a consecutive odd integer question. So we have consecutive odd integers. Again, we have to skip one integer if we're kind of going up chronologically here. 4 consecutive odd integers such that the sum of the first and fourth is 25 greater than the opposite of the third rather. So I'll read that again. Find the 4 consecutive odd integers such that the sum of the first and fourth is 25 greater than the opposite of the third. Okay, so let's start with our generic 4 consecutive odd integers. Let's use x this time just to shake it up. X plus 2, x plus 4, x plus 6, there's 4 of them. The sum of the first and fourth, so x and x plus 6, is 25 greater than the opposite of the third. Opposite of the third. Well, the third is x plus 4. The opposite of that is minus x plus 4. Maybe it would help to put brackets. I don't know. But that's what the opposite of x plus 4 would be. And now we've got an equation we can solve, so we're going to go ahead and do that. I'm going to distribute that negative 1, so I have a negative x and a negative 4. Add x to each side. Okay, so we got x equals 5. And so if I need to know those 4 consecutive odd integers, I can now determine, okay, 5 is the first one, 7, 9, and 11. There we go. Knew I had it in me. Alright, so we got our consecutive odd integers. Let's take a look at some of these decimal and fraction word problems. These are another situation where we're going to be using a equation to solve these word problems. Alright, we got Lopez using a 5 iron, but the ball covers only 4/5 of the required distance. If she hit the ball 112 yards, what was the required distance? So the way that you can think about this is that we know that 4/5 of some number is going to equal 112 yards. So the way you find 4/5 of something is you multiply it by 4/5. So I would write this out as 4/5 times x equals 112, right? And then we've got an equation that we can solve. I'm going to multiply by a reciprocal here. And what happens is I'm left with x on one side. And I can actually cross reduce here. So I can divide 4 by 4, which is 1, and then 112 by 4, which is, I have to do my little math here on the side. I'm recording this on a Friday, can you tell? 28, there it is. So we have 28 over 1, which we then would multiply by 5 over 1. And 28 times 5 is 140. So 140 yards is the required distance. And again, we can kind of go back to the original 4/5. 140 yards isn't that far from 112, so it's a little bit above. So that should kind of follow with our common sense test for this. All right, let's look at the next one. Julie guessed that the total was 30.24, but this was 7.2 times the total. What was the total? Well, if we know that 30.24 is, get rid of that scribble. If we know that 30.24 is 7.2 times the total, then we know that 7.2 times x, which will be for our total, is going to be equal to 30.24. And again, you know, setting this up and thinking about how these values relate to each other is important. All we have to do is divide it out, and we'll figure out what x is. It's a good opportunity to do a little decimal long division. We all love that. Moving the decimal out of the divisor. 72 goes into 302 4 times, I believe. 288. And 72 goes into 144 twice. So we actually have 4.2 as our value of x. All right, one more. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets had been printed? So if we know that there are 420 tickets left, and 3/4 of the tickets have been sold, then that means that 420 actually represents 1/4 of some value, right? 420 has to be a quarter of what was left if 3/4 are already gone. So I might write this out as 1/4 times some value is equal to 420. Again, recognizing that 420 represents a quarter of the total number of tickets if 3/4 have been sold. From here, I'm going to multiply by the reciprocal to solve, which means multiplying 420 by 4. And so, you know, once again, I'm going to do my little math here on the side because, you know, as I do. And I end up with x is equal to 1,680 tickets total. All right, take a look at the practice problems for these. Okay, problem set 78 on rational equations. Interesting piece here that we have a bunch of rational expressions kind of being added together, and it's pretty annoying because now we have these, dealing with fractions and equations is not fun. So the technique that we're going to use here is all about multiplying each side of the equation to create an equivalent equation by finding the least common multiple of the denominators of the rational expressions within the equation. And this is what I mean by that. So as I look at this first example, where we have to solve y over 2 plus 1/4 equals y over 6, I'm really looking at the denominators and I'm saying, man, if I could just figure out a way to multiply each side by something so that all of these fractions have a denominator of 1, then I'm not dealing with fractions anymore. I look at 2, 4, and 6, and I recognize that actually the LCM of these is 12. Any common multiple will do, but the least common multiple is probably the easiest to work with. Once I know that, then I can take 12 and I can multiply it by each side of the equation. And it looks like this. Okay, I'm going to distribute that 12. Maybe I'll throw it as 12 over 1. And what happens is that I end up with 12y over 2 plus 12 over 4 equals 12y over 6. Now, you could have cross-canceled there for sure. Or you can just kind of reduce like I'm about to do. 12y over 2 is 6y. 12 over 4 is 3. And 12y over 6 is 2y. All right, and now hopefully we can agree that this is a much more enjoyable place to be with equation solving. 6y plus 3 equals 2y. I'm going to isolate my y's like you do. I end up with negative 4y equals 3. I'm going to fix that 4. Divide each side by negative 4. And voila, there we are, y equals negative 3/4. There we go. I don't want my 4's looking like y's. All right, so similar situation over here. We do have to be careful, though, when we're multiplying by our terms. Now, I notice that we have a 2 and a 7. I'm looking for common multiple. I'm going to go with the LCM, which is 14. And what that's going to do, again, the goal is to eliminate the fractions within our equation. And so I'm going to take 14 over 1. I'm going to multiply it by the left side. And the right side to create an equivalent equation. Okay, so what happens is that I end up with 42 y over 2 plus, now I'm going to put the 14 outside of this this expression here rather than distribute it, and I'll show you why in a minute. Ultimately, I could distribute that, and that would be the mathematical way of an approach I could take. But the reason that I'm not doing it is because I can actually simplify before I distribute, which is going to save me a little bit of work. So let me just take the 42y over 2. That becomes 21y when I divide it. And from this point, I can actually divide 14 by 7 to get 2. So that gets me here. So it saves me just a little bit of work with the distributing. Now I am going to distribute the 2. So I end up with 16 minus 8y equals 42. And I get 13y when I combine like terms. 13y equals 42 minus 16. Holy Toledo, it's Friday. I'm doing it. 26. and y equals 2. Give some of these a shot. Just remember to multiply each side by a common multiple, ideally the least common multiple.